So today we will learn what is rate limiting enzyme. What is rate limiting enzyme? Rate limiting enzyme. Now, as the name suggests, what is rate limitation? Rate limitation is kind of limitation. Limitation of what rate? Limitations of a metabolism, of a metabolic rate. If we see in metabolism, there are different pathways. Say I for example, I will write an example to make you understand. Say there is a central metabolite which we say as O. Now from O, this is the metabolite. There can be different radiating pathways, though this is a metabolite O. So there can be different metabolic pathways from O to A, say to B, to C, to D. There can be from O, there can be P, Q, R, S. There can be another pathway from this metabolite, say M, N, O, P. And these are the end products of the metabolites, P, D, D, P and S. And these pathways are converted by different enzymes. Say for here it is X1, it is X2, X3, X4. Say here it is M1, M2, M3, M4. Likewise, these conversions, each of these conversions, say from O to A to B, B to C, is done by this respective enzymes. Say X1 converts O to X. Here M1 converts O to M, M2 converts M to N. So these are the metabolites and these are the enzymes. These are the enzymes M1, M2, M4, and these are the pathways. Now what is a rate limiting enzyme? A rate limiting enzyme is an enzyme which will tell that if we have O metabolite here at the central, which pathway will be running. Which pathway will be running. So if we want to run this pathway, we have to first convert O to A, or if we have to run this pathway and get P as a product, we need P as product. Say we need P as product, or we need D as product. So if we need D as product, we have to run this pathway. If we need P as product, we have to run this pathway. If we need S as product, we have to run this pathway. Now if we need this pathway, if we need P as product, we have to either stop this pathway and get to this pathway. So we have to stop this pathway, and we have to run this pathway. So to run this pathway, we have to first inhibit these pathways and limit these pathways. So what is a rate limiting enzyme? I will come to that. Before that, I just gave you the concept of these different pathways and different enzymes acting on these pathways. Now, to limit a particular pathway, you need to limit it very early. So that if O to A somehow happens to occur, someone manages to occur, and you need to limit this pathway. So some A will get converted to B and some B will get converted to C. So there will be an absolute anarchy in metabolism. Because these metabolites will get accumulated and will not get product. So there will be different types of metabolites. So when we want a particular product, we turn on a pathway and say we turn on this pathway to get D. If we want to get P, we turn on this pathway, and when we turn on this pathway, we actually depend on the rate limiting enzyme of this pathway. Because these are the master enzymes, these rate limiting enzymes. They will actually tell whether this pathway will occur or not. And depending upon their properties, depending upon their actions, the metabolism is regulated. All of our different metabolic pathways are regulated. Now, what is this importance of this rate limiting enzyme? What are the primary properties of this rate limiting enzyme? The importance of this rate limiting enzymes are that these rate limiting enzymes will govern whether any pathway will occur or not. It is being regulated. These rate limiting enzymes are being regulated by different important molecules of our body, say hormones, say different types of messengers, chemical messengers, different types of transcription factors, different types of proteins will regulate, drugs will regulate these rate limiting enzymes. So these rate limiting enzymes can be heavily regulated, and there are in vivo regulations inside our body, inside our physiological milieu, that there are in vivo regulations of this pathway. And these in vivo regulations inside our body, there are different metabolites which will regulate this rate limiting enzymes, which have the ability to regulate these rate limiting enzymes. So these are the highest regulatable enzymes. So if somebody is not regulated, you cannot control his actions. So rate limiting enzymes are the highly regulated enzymes. Those enzymes whom we can regulate, we make them rate limiting. We make them rate limiting. And what else do we do apart from make them rate limiting? And what are the other properties of rate limiting enzyme? They should reside in the initial part of the pathway. Say X1 should be the rate limiting enzyme. X1 should be the rate limiting, and not X2, not X3, not X4. Because if X1 was not the rate limiting enzyme, then we would have obtained A or B or C, and this product would have accumulated. Instead of getting D as a product of the pathway, we would have got a byproducts of A, B and C. So to limit these byproducts, so these A, B, C's are not required. We actually need D, the ultimate product of the pathway. So we block or stimulate. If we need this pathway, you stimulate this rate limiting enzyme so that the pathway goes along. And this rate limiting enzyme is the primary enzyme of this pathway. It becomes the first or this rate limiting enzyme. So which one is the rate limiting enzyme? X1, X2, X3, X4. You should note that X1 should be the rate limiting enzyme. Any enzyme which is in the initial steps of the pathway should be the rate limiting enzyme. Now, what are the other properties? The other properties are this step should be the other property. Just now it should be the highest regulatable, that one that I just mentioned. It is the highest regulatable enzyme of this pathway. The third property is it should be unidirectional. Unidirectional means if I require D, I will stimulate X to make O to A, and this will be unidirectional. That means if somehow O happens to get changed to A by X, this will not get converted reversibly to O. And how do we do it? We do it by a change in currency. Suppose you are sold out, means you are giving a suppose some merchandise is sold off, means once you pay, it gets irreversible, the process gets irreversible. So this is a payment expenditure of ATP that makes this pathway irreversible. So generally in this rate limiting step, there is a energy conversion takes place. There is a expenditure of an energy, and this expenditure of energy makes the rate limiting step the committed step of the pathway. And another very important property that I'll explain. I just told you what is the km of an enzyme. So these enzymes M1, M2, M3, M4, they have all individual kms for their substrate. M1 has a particular affinity towards O, M2 has a particular affinity towards M, M3 has a particular affinity towards N, M4 has a particular affinity towards O. Now, these affinities when compared these affinities of the enzymes when compared with their substrates, these affinities, the rate limiting step, in case of the rate limiting step, this affinity, it is very important, it's a very important point. The affinity for the enzyme towards the metabolite, towards its own metabolite, say for the initial step, this M1 is the enzyme and O is the metabolite, O is the substrate of M1, and the affinity of this binding of this, the Km of this, it should be the highest value, it should be the lowest affinity. M1 should possess, that means M1 should possess the lowest affinity or the highest Km value or the highest Km value for its substrate, in respect to M1 should possess the highest affinity or highest Km value for its substrate in respect to the other downstream affinities for their individual substrates. Means if this affinity is the lowest, so say O2M happened and M1, O2M happened and M1 is the enzyme. So if this affinity is the lowest and then M2N happens with M2. Now if these two affinities, enzyme and the substrate affinities are compared, if this one has the lower affinity, so this reaction will be the slower reaction. That means if this reaction happens, this will be the faster reaction. The first reaction will be the slower reaction and this reaction will be the faster reaction. So if this reaction somehow happens, this will not be the trouble. This reaction will always occur because this is the better affinity enzyme and this is the lower affinity enzyme acting on this. This is the lower affinity enzyme acting on its substrate here. So this step becomes the rate limiting step because it has the lowest affinity for its substrate or the highest Km value of this substrate. Lowest affinity means highest Km value. So this M1 will have this initial enzyme which will be the committed step, which will have it, which is the highest regulatable enzyme, will also have the lowest affinity for its substrate. It will have the lowest affinity of its substrate compared to the downstream pathway events, compared to the downstream events, the downstream enzymes with their substrate affinities. When these substrate affinities are compared, the lowest substrate affinity should be that of the regulating rate limiting enzyme. And the last thing is that this rate limiting enzyme should govern the outcome of the metabolism. The rate limiting enzymes governs the outcome of metabolism. So if you are being able to inhibit a rate limiting enzyme, you will be able to block a pathway and the metabolism will shift towards something else. Say when we are starving and we need to then conserve glucose, so we need to get glucose, we need to stimulate glycogenolysis. Means glycogenolysis is a breaking down of glycogen to glucose. So all our glycogen should primarily break down to supply us glucose because we are now starving. So for that we need to primarily block down glucose conversions to other pathways. We need to block down glucose conversions to fatty acids, glucose conversions to amino acids. So these pathways should be blocked and then some pathways, the glycogen breakdown pathways should be started. So some pathways, there are different needs in metabolism which has to be taken care of. So whenever there is a hormone, it will change a pathway. It will change certain pathways. Whenever a hormone arrives in this metabolism, regulates we know that hormone regulates metabolism. So whenever there is a hormone that arrives, when a hormone is secreted, it will regulate metabolism and it will regulate metabolism by acting on these rate limiting enzymes. So these rate limiting enzymes are very important for studying enzymic actions because these enzymes actually regulate metabolism and they regulate the whole body physiology. So briefly, I'll just explain you what are the properties of rate limiting enzymes. The properties are, it should govern the initial step of the pathway. The rate limiting enzyme should be there in the initial step of the pathway. It should be the committed step. It is the committed step because when this rate limiting enzymes, this step has occurred, the pathway will get complete. This step will require energy conversion. Requiring energy conversion means the commitment, where from this commitment comes? Because there is an expenditure of energy. You have spent some money for that. You have spent some money for that, requiring energy conversions. The rate limiting enzyme should be the lowest substrate affinity enzyme or the highest Km value for its substrate. It should have the highest Km value for its substrate compared to the later enzymatic reactions of that pathway. The first reaction, if it has the highest Km value or the lowest substrate affinity, it will be very slow, and it will not, if this reaction happens, the entire pathway will be taken care of. The entire pathway will certainly occur, and that means that the rate limiting enzyme should have the lowest substrate affinity. If it had the highest substrate affinity, then the first step would have got converted and the later steps will not get converted. The later step will sit and stand because the first step is the fastest step. It should not be like that. The first step or the rate limiting step should be the slowest step. It is the highest regulatable enzyme. The rate limiting enzyme should be the highest regulatable enzyme of the pathway. Means all the hormones, all the metabolites, all the drugs should be able to regulate this enzyme. So that the rate limiting step determines metabolism, so it gets the primary importance. It is the highest regulating enzyme in the rate limiting step. And it should be unidirectional determining the outcome of metabolism of that pathway. By the metabolism takes place by different pathways, different types of metabolisms. We can have a shift from carbohydrate metabolism to protein metabolism to lipid synthesis. Say we are eating huge amount of carbohydrate, so fat is getting stored. How come the fat is getting stored from carbohydrates? Means carbohydrates are getting converted to acetyl CoA getting converted to fat. And so in that way, glucose gets converted to glycogen. We know in the liver, in the muscles, glucose gets converted to fat in the adipose tissues. So we are eating only carbohydrates, but we are getting fat. So if we are eating less amino acids, say we are eating less proteins, so then we will conserve nitrogen and we will transfer the amino groups of our broken down proteins to those glucose, to those metabolites of carbohydrate metabolites to make them amino acids. So we can, in different, according to the different needs of our body. So if we are conserving more nitrogen, if we are eating less nitrogen, less proteins, we will be conserving nitrogens of our body, and it will be making amino acids from glucose. So there are different needs of our body in different situations, in different metabolic situations. We need to regulate our enzymic activities. So for that, rate limiting enzymes are very important, and rate limiting enzymes actually regulate the whole of biochemistry. Thank you for listening to me.